Ever seen those pictures of massive gold nuggets?
Yeah,
The kind that make you dream of heading to Alaska?
striking it rich.
Exactly. Well, get this. We're diving into research today that links those golden giants to earthquakes.
Really?
Yeah, earthquakes.
Interesting.
You shared an article with me from Nature Geoscience, and it basically says earthquakes might be how these huge gold nuggets form.
Yeah, it's a fascinating idea and a really interesting area of study.
I was so curious about this when I saw it.
Yeah.
Earthquakes creating gold. It's not exactly common knowledge.
It's not something you hear every day, that's for sure.
But before we get ahead of ourselves, let's talk about what we already know about gold formation.
Okay, so we know that gold often forms in deposits where fluids from deep within the Earth's crust seep into cracks in quartz. Over time, as conditions change, the gold precipitates out of these fluids.
Like a filter.
Yeah, you can think of it that way, kind of like a natural filtration system.
There's always a but, isn't there?
Well, there's this puzzle researchers have been wrestling with.
Okay, lay it on me.
The size of these quartz cracks.
Yeah.
Even if we're being really generous with our estimates, it doesn't explain how some of the massive gold nuggets we found could have formed.
So like trying to pour the ocean through a straw.
Basically, the scale of these cracks just doesn't seem to add up to the size of the nuggets.
So what's the solution? What's this research say?
This is where it gets really interesting. They focused on something called piezoelectricity. Have you heard of
This
that?
rings a bell.
It's a property of certain materials, including quartz. You know how some materials can generate an electric voltage when you apply pressure or stress to them?
Vaguely. Like those light-up sneakers back in the day.
Exactly. That's a great analogy. The pressure from your step created a voltage that lit up the shoes. Similarly, when quartz is squeezed during an earthquake, the stress creates an electric field.
Okay, I'm with you so far. We've got earthquakes, quartz, and electricity. But how does this actually make gold?
That's the million-dollar question, right? The researchers think that these electric fields generated by the stressed quartz act like a jumpstart for gold nanoparticles in the surrounding fluid. Normally, these particles are way too small to stick together and form nuggets.
So the electricity is like a catalyst.
Exactly. The electric field makes these nanoparticles much more likely to clump together, kind of like magnets being drawn to each other.
So they're changing how these tiny gold particles behave.
Yeah. And the best part is they didn't just theorize about this, they actually did an experiment to test it.
Oh, so they really put this to the test in the lab.
They simulated the pressure of an earthquake on quartz, submerged in a solution with gold nanoparticles.
Yeah.
It worked. They saw the gold nanoparticles accumulating on the surface of the quartz. Not randomly either. They were forming larger deposits, drawn together by that electric field.
Wow, so there's visual proof this could actually be happening.
It wasn't just a hypothesis. They were seeing the formation of larger gold deposits driven by piezoelectricity. It's a huge step forward in understanding how those massive gold nuggets we all love to see pictures of might actually form.
That's incredible. So they've shown this can happen in a lab, but what about in the real world? Where does this actually play out?
So this research was looking at a specific type of gold deposit called an orogenic deposit.
Orogenic.
It's a mouthful, I know.
Yeah.
But basically it refers to deposits formed in areas where continents have collided.
So places like the Himalayas, the Alps, the Andes, those huge mountain ranges.
Exactly. Those collisions create the immense pressure and seismic activity you'd need for this piezoelectric process to really get going.
So now we'll be picturing all that gold forming under those mountains.
It really changes how you see things.
It really does. This is just incredible. But what about those old prospectors? Does this research change how we should search for gold now?
It might. You see, traditionally, prospectors looked for signs of gold-bearing fluids, specific rock formations, or changes in the minerals.
So do we need to bring seismographs with us now instead of digging?
It's not quite that easy. But this research does suggest that we should be looking at the seismic history of an area.
Okay.
Places that have had a lot of earthquakes, especially these orogenic zones we're talking about.
Right.
They could have more potential for those large gold deposits than we thought.
So we might find gold mines in places we didn't even think to look before.
Exactly. Looks like we've been missing half the puzzle this whole time.
This is really groundbreaking. But I'm guessing this research brings up even more questions. What don't we know yet?
Oh, there's always more to learn. One thing is, how long do those earthquake forces need to act on the quartz to really create those big gold deposits?
So is it like one big earthquake does it? Or does it take many earthquakes over millions of years?
That's what we need to find out. It could be that one powerful earthquake is enough for some gold deposits. But to get those really massive nuggets, It might require those piezoelectric forces from repeated seismic events over a very long time.
So we can't just find an area with some earthquakes in its past and start celebrating.
Not quite. And here's another interesting question. This research makes you wonder, why do some quartz cracks, even with similar earthquake forces, have lots of gold, while others barely have any?
That's so strange. What could explain that?
It's a puzzle researchers are trying to solve. There could be subtle differences in the quartz itself, like its crystalline structure, or if there are trace elements in it. Those things might affect how the piezoelectric effect works.
So the quartz itself could hold clues about where to find the gold?
Maybe. And we can't forget about the gold-bearing fluids themselves. Their composition, how hot they are, their acidity. All of those factors could be interacting with the piezoelectric effect in ways we don't understand yet. And that could explain the differences we're seeing in those gold deposits.
It seems like the more we learn, the more we realize how much we don't know.
That's the thing about science. Every answer leads to more questions. It keeps us exploring. It really makes you think about how much is going on beneath our feet that we don't even realize.
Yeah, this study really challenges how we think about gold deposits.
It shows how these powerful forces, earthquakes, electricity, even the makeup of the minerals themselves are all connected.
It's amazing how much energy there is within the Earth. We tend to think about geology as something that happens over millions of years. But then you have these sudden events like earthquakes that can completely reshape things.
And who knows what else is out there? What other secrets or treasures are waiting to be discovered because of this new understanding?
It's like we're finally starting to understand the language of the Earth.
This research with piezoelectricity and gold formation, it opens up so many possibilities, not just for finding gold, but for understanding how all of the Earth's systems work together.
It reminds us that science is always evolving. There are always more questions to answer, more pieces to add to the puzzle.
And you never know where those answers will come from. Who would have thought that gold, those beautiful, valuable nuggets, could be formed by something as powerful as earthquakes? It's incredible.
It really is. So the next time we hear about an earthquake or see a piece of gold, we should remember those incredible forces that have been shaping our planet for billions of years.
Forces that are still at work today, and we're slowly starting to uncover their secrets.
Well, on that note, we'll wrap up this deep dive. Thanks for listening, and we'll see you next time.